Hello everyone, welcome to this demo session. Today we are going to see an interesting problem and how to solve the problem using Hadoop. The problem we are going to see today is not only interesting but also has tangible results. So what do I mean by that? Meaning the application of this problem can be applied to our day-to-day life. And we're going to see how and why is that. Okay? So first let's define the problem, right? Then we'll see why we need Hadoop to solve the problem, and then we'll solve the problem using Hadoop. Okay? So before we go any further, we'll explain the data set that we're going to use. So in today's example, we're going to look at a data set called million song data set. Okay? So what is a million song data set? A million song data set has metadata for million songs, right? It doesn't have any audio files in it, but it has metadata for literally million songs. So these songs are collected from across the world. Okay, so it's a collaborative effort by the Econest and Lab Rosa. The Lab Rosa is part of Columbia University, so it's an open source project. Okay, so it's a very good initiative. And the total size of this data set is 280 GB, right? So it's a very big data set. So it is a very big data set. And the format of this data set is HDF5 format. Okay, but we can easily convert that into the text format so that we can use that format in Hadoop. Well, Hadoop can also be used to work with other formats as well. Like you can work with image files, PDFs, JSON, you name it. Okay, but today we're going to look at processing a file which is in text format. All right. So the next question is, where can we get this data set and what is in the data set? Okay. So getting this data set is very, very simple. It's right here, right? So you go to Google, you type on million song data set. You know, you'll see this link. It's labrosa.e.columbia.edu/million song. Okay. So as I said, you know, it's an open source project, so anyone can easily download the data set. Okay, you can download the whole 280 GB of this data set. All right, so now we know this data set has metadata for million songs, right? But let's see what is in the metadata. Okay, so to look at that, let's click at the description, right? So below is a list of fields that you can find in this data set. It has details about the artist, it has details about the album itself, it has details about the artist's location, the latitude and longitude, which we are interested in for this very specific example. All right. It also has metadata or information about the song itself, like what is the what is the bars, you know, and the duration of the song, what is the beat of the song, what is the tempo of the song, what is the loudness of the song, right? The other piece of information that we are very much interested in is the hotness, the song hotness. You know, what does it really mean? It means about the likability of it. Okay, so it's a decimal digit. The higher the number, the more likable or more hot the song is. Okay. So it is a decimal digit between 0 and 1. Okay, it goes from 0 to 1. So the higher the value, the more hot the song is. All right. Okay. So now let's look at the problem we're trying to solve. So we know about the data set now, right? So we're going to define the problem now, and we're going to see how to solve it using Hadoop and why Hadoop, of course, right? Good. So the problem that we're trying to solve today is we're trying to find the top 10 hot isolated songs from this data set. Okay, so let's assume you're a music buff, right? You love to hear music and you want to explore music, right? So how do you explore music? Well, with this data set, you know, you can actually find the top 10, not just the top 10 hot songs, but top 10 hot isolated songs. Isolated meaning you wanted to find songs which you haven't heard before, right? You wanted to find songs from artists who are remote to other artists, okay? For example, let's say you have a lot of artists in the US, right? Or let's say you have a few artists not closer to the proximity of US. For example, from India, for example, let's say we have A.R. Rahman from India, right? The average distance of A.R. Rahman, from India to all other US artists is going to be high, right? So he becomes an isolated artist, compared to the other artists in the US. So similarly, you can find an artist in Africa, you can find an artist in South America, who are isolated to other artists, meaning their average distance from other artists is high, okay? And they're going to find such top 10 hot songs from those isolated artists. Does it make sense? Good. And what we're going to do, we're going to visualize the problem itself, right? So we're going to find the solution and we're going to visualize the solution. So once we have the list of artists, right, we're going to plot the artist in maps.google.com, something like this you see on the right, okay? So once we plot it in a map, then we have a very visual understanding. We can even browse the data, see who's from India, for example, and explore the data as such. All right. Okay. So now we have seen the data. Now let's see why we need Hadoop to process the data, right? Before we go into how we can fix or how we can find a solution to this problem, let's see why we need Hadoop to do such processing. The very first reason, as I said in the initial overview of this data set is huge. It has 280 GB, right? So if you want to process the 280 GB to find an answer for a problem, you have to access this data set in full, right? And if you're going to access this data set sequentially, you have a problem, which is the time parameter, right? It's going to take hours and hours for you to execute something on this data set, something on this whole data set, and come to a conclusion. In this time and age, we don't have a lot of time. That's for sure, right? So we have very limited time, and if you're saying hours and hours, we're looking at over. It could be over 14 hours, and that's not going to cut out, right? So we can't process this sequentially, because of this time constraint or the issue. So what we have to do is we have to process this data set in a distributed fashion using Hadoop. Okay, so Hadoop is a distributed framework, right? Which deploys many number of nodes or computers to distribute the load across all the nodes to get the work done faster. Okay, so it's a difference between one person doing a job between like 10 people doing a job at the same time, right? So that's the power of Hadoop. All right. So now, what is the tool we are going to use in Hadoop to solve this problem? So there are many tools in the Hadoop ecosystem that you can use to solve this very problem, right? But for today's example, we're going to use Apache Pig to solve this problem. Apache Pig is very easy to use, and you'll see why it's very easy. It's literally instructions in English language, right? It is very easy to follow, and very easy to write. Okay, so let's first look at the overall solution itself. Before writing any script in Apache Pig, let's look on a very high level how we're going to solve this, right? The first thing you're going to do is you're going to load the data, right? This is just a sample data, just to visualize the problem, visualize or understand the problem itself. So we'll be loading the data first, and we'll be filtering the data. So why are you doing this filtering? You want to remove all the invalid data, right? For example, if you have a song entry in the data set, right, which is which doesn't have any location, for example, you want to remove that, right? Because if there is no location, or in this case latitude and longitude of the artist, you can calculate the average distance of this artist compared to the other artist, and hence you can see how isolated the artist is compared to the other artist, right? So that entry should be removed first. And also we want to show what we want to work with, the hottest songs, right? So for that criteria, we're going to say we're going to take a song which is 0.6 in the hotness level and above. Okay, anything else we'll just ignore it. All right, and then we'll cross the data. Okay, what is crossing? You'll take the data sets, two identical sets of this data set, and you'll do a cross, meaning the first record, it will be crossed or will be joined, will be all other records from the other side. Okay, so the song one will be crossed with all other songs. So let's take a closer look, right? For example, here you can see song one is crossed with song 1, song 2, song 3, right? Similarly, song 2 is crossed with song 2, 1, and 3, right? Okay. So now, after the cross is done, we want to do a filter again. Why? Because we wanted to remove the common joins. For example, song 1 in the previous slide, song 1 is also joined with song 1. We don't want that, okay? So we're going to remove the common joins. And now we're going to calculate the distance using the latitude and the longitude, okay? I have just specified location here, but in the real example, we're going to use latitude and longitude. And how we are going to calculate the distance with latitude and longitude? Well, there is a library to do that. We don't have to write any code. There is an open source library to do that very thing, okay? All right, so now we're going to apply the grouping, and this is the crux of it, right? So this is the crux of this program itself. You're going to apply a grouping, right? And then you're going to calculate the average distance. Once you're done with that, you're going to limit the data to just the top 10 artists, okay? The top 10 artists getting the top 10 hot isolated songs. Very simple, isn't it? Right? It's very simple. Apache Pig is very simple. Hadoop itself is very simple once you understand the core concepts. All right. So now we know how we are going to attack this problem on a very high level, right? So let's look at the Apache Pig script now. Okay. Again, it's very easy to follow. I have included a lot of comments here, but it's a very simple script. Like a one-page script, right? The first thing you're going to do, you're going to load the song data set, okay? And then you're going to filter. As I said, you're going to filter on the song hotness. I'm now filtering here for any songs which has the hotness count of 0.5 and above. And then you're going to do a cross, right? On the filtered data, you're going to do a cross, okay? And then here you're calculating the distance using this library, okay? So and this library is actually registered right here, okay? So as I said, you don't have to write a lot of code to calculate the distance using the latitude and the longitude, okay? Because the open source library is already available for us to do that, okay? And the next thing, and very important thing of this problem, is the grouping and the aggregation. This is the crux of the problem. Okay, so the rest of the things are pretty much straightforward. Loading, filtering, crossing the data. It's pretty much straightforward. But this is the crux of the problem: with grouping the result set, right, to find the average distance. Good. So once you have that, right, you're going to limit the data set. All right, and that's it. So once you limit the data set to top 10 or top 50 or top 200, so you can store the output. You can store the output in a format which you can actually use the exact output to plot in maps.google.com. Okay. So now let's go ahead and see how we can run this actual example. All right. So I'm going to connect to a Hadoop cluster. Okay, so in this training, you will get access to the cluster. Okay, so let me connect to the cluster again. All right, so it's right here, right? So I'm going to type in. I'm going to log into the cluster. So this cluster is a 4-node cluster. This cluster is like a 4-node cluster. Okay, so it's a real Hadoop training environment where you can actually deploy or run your jobs against this cluster. You don't have to work with just one node or like a virtual image from your laptop. You can actually log into a real cluster and try your examples out. It's a good way of learning, right? Okay, perfect. So now we know about the data set. We know about the problem. We know how we're going to solve the problem. All we have to do is just execute it and look at the output and look at the plot the output in maps.google.com. Okay, all right. Let's run this example now. Okay, so we saw the script. I've already copied the script over. The data set is also copied over. We're going to run this example on a very small data set. Okay, you can obviously run this data set on all the 280 GB. But it's going to take, on a 10 or a 12 node cluster, it's going to take about like 60 to 70 minutes. Okay, so we're going to run it on a very small data set, because we have very limited time here. All right, so that's it. So we're running a script, a pig script, and we're saying pig-x, right? So this is going to run. So what this is doing in the backend? So it's getting this data set, right, and it's applying the instructions that we gave in our pig script. Right, it's going step by step. All right, and while it converts all our instructions into a series of MapReduce jobs. Okay, so we'll be learning a lot about MapReduce in our training, but it's going to convert this big instructions to a series of MapReduce jobs, and it's going to submit those jobs in the Hadoop cluster. Getting the result set. So now the result set is ready. So let's look at how it actually looks like. Okay, so the result set is saved under, say, these songs. We'll see 2 files here. I'm going to open the part R. Okay. All right. So now, as you can see, the result is actually formatted for maps.google.com already. Right? It has the latitude and the longitude, the name, the group name, the band name, the hotness factor, and all that. Right? And the song ID class. So with this information, you can actually plot this in maps.google.com. So I'm going to show you, how the map looks like, right, for top 200 isolated songs from the million songs. Okay, and it's very easy to plot this data in maps.google.com. So for example, you take your output, and you can just put the output right here, and that's it. In the HTML file. The HTML file has some script right here to display the map itself. All right. So if you open it right here, so there you go. It's neatly plotted and across the globe. Well, the interesting thing is, let's see who from India is on the list, right? All right, so we have A.R. Rahman on the list for a song from Tulsi, right? The song hotness is 0.52, and it also gives the average distance when compared to all other artists in the world. There are a few other artists too. Ananda Shankar, right? So you can actually it also has the links to the song itself. So where you can get the song, where you can actually download the song from. Actually, you can download the song. They're all open source too. All right. So this example, you can actually apply these examples to predictive analysis. Meaning, for example, let's say you like a restaurant, right? What other similar restaurants you would like, from the same set of search criteria, right? If you have a data set full of restaurants, for example, from Yelp.com, you can do some real cool analysis like that, right? Or, for example, if you like a movie, with the similar characteristics of the movie that you like, what are the movies would you like? So you can rate those movies. For example, Amazon.com, they can use, a similar concept or a similar application wherein they see what products you like, right? And then they show you similar products. All this is possible, with big data because you have tremendous amount of data, and solving the problem is also easy. It's also easy using Hadoop. Okay. Hope you really like this session, and thank you so much for joining.